Hi, everyone. I'm here to tell you today about how to calculate a PSTH. Well, what is a PSTH? It stands for peri-stimulus time histogram, and it's a way of looking at what the neural activity does around a particular event. Like, for example, if you're showing a subject a visual stimulus. Well, why would you want to calculate that? Well, remember that the big goal here is that we want to understand how the brain does things, like represent sensory events that are occurring in the animal's visual field. And in order to do that, we have to find a way to visualize the data as it's coming in a way that makes sense. And the heart of the problem here is that when you're conducting an experiment and measuring neural activity, it isn't really immediately set up in a way that you can actually see what the visual stimulus or whatever stimulus you're studying is actually doing to the brain. So let me show you an example of this. Okay, so let's suppose that you're recording neural activity in the brain. Well, what does that look like? Basically, you're going to see a bunch of action potentials. And of course, those have a lovely shape, but I'm just going to schematize them here as little lines. This is what we might call a raster plot. Sorry. So as the data is coming in, you're going to collect a bunch of spikes, which is cool. And they might look something like this. Each vertical line here is meant to schematize one spike. Okay, remember, we want to understand here what visual activity is doing to the brain. And so let's suppose in this experiment that we have showed the animal a visual stimulus at a few different moments in time. Let's suppose we flashed a square of light and it occurred here, and it occurred here, and it occurred here. And we might have like a regular stimulus presentation, or it might be a bit irregular, and so on. So you can kind of get the idea that just by looking at this, that there's a little bit of structure that's happening here, right? Every time you see one of these red squares, there's a few spikes that happens afterwards. So that kind of gives us a hint that this visual stimulus is maybe driving some neural activity in the brain. But we need a way to quantify this, to look at how systematically a visual stimulus is driving neural activity. Well, how on earth are we going to do that? Well, what we're going to do is take all of this process data and we're going to think about each visual stimulus as having kind of a box around it. Okay, so I'm going to draw a box around each of these visual stimuli. And the box is going to start a little bit before the stimulus came on, and then the box is going to end a little ways after the visual stimulus came on. And as you're going to see in a moment, this is going to be a good way for us to understand what's happening to the brain when the visual stimulus is presented. Okay, great. So now let's give ourselves a set of axes. We're going to have a horizontal axis, which is time, we'll call that T, and a vertical axis, which is going to be the neural response or the spike count. So I'm going to call that spikes per second. We'll imagine that perhaps this green window that we've just drawn is maybe 1 second long. Okay, great. So now let's think about where the visual stimulus would be in this schematic. Well, the visual stimulus would be, let's plot the neural activity relative to the visual stimulus. So this moment here, that's going to be the onset of each of these stimuli here. Okay, so then let's imagine dividing up this box into a bunch of sub boxes, each of which is maybe 100 milliseconds long, or a tenth of a second. Okay, and the idea here is that we're going to have a bunch of mini boxes and we're going to count the number of spikes in each of these boxes. And then we're going to call that the spike count. And then we're going to have plot the average spike count on the bottom, the spikes per second on the bottom. Okay, so let's think about what's happening here. So if you think about in each green window, the very first box before the stimulus came on, there's usually no spikes there. There's no spikes in this window, nothing. No spikes in this window. This one is a little hard to tell, and I did that on purpose, as you'll see. And in this one over here, there's nothing. So before the stimulus comes on, so in the time window before that stimulus comes on, the spikes per second is very low. In fact, in this case, it's actually 0. So let's just draw it at 0. Okay, 0. Okay, and then around the time that the stimulus comes on, actually, there's really no spikes at that moment either. And this kind of makes sense, remember, because it takes a little while for the visual stimulus to get into the brain. So even for the moment that's right after the visual stimulus comes on, there's really nothing there. But then when we look in this third window, oh boy, we're starting to get some spikes here. We got 2 there, we got 1 there, we got 2 here, we got 2 here. All of a sudden we have a much bigger response. So that's going to go up. And then it's a bit variable. Sometimes there are no spikes in subsequent windows. Sometimes there's a couple. It basically kind of comes down. Okay, so this is great. So this is basically all you need to know. This is a PSTH, peri-stimulus time histogram. And I think now you're starting to understand it, right? It's peri-stimulus, because what we're interested in is what happens around the time that the stimulus comes on. That's why we've aligned the activity to the moment that that red box is appearing in the animal's visual field, sorry. But we're plotting the data a little bit before and also a fair amount of time after. So that's why it's called the peri-stimulus time histogram. Peri just means around the time of the stimulus. Okay, time, that makes sense because we're just counting different windows in time. And in what sense is this a histogram? Well, it's probably exactly like the histogram that you have plotted, many times in your life, starting probably with 6th grade math, in the sense that what each of these moments in time is all we've done is we've counted spikes in a particular window, and we plotted the number of spikes that were in that window. And the way that I've drawn it here, I kind of smoothed it out a bit, which we might do if we have many instances of these stimuli coming on. You actually end up getting a smooth function. But in the end, all we're really doing here, all these numbers reflect, is counting the spikes in each window and averaging those together. So that's a peri-stimulus time histogram. One last point. You'll notice here for this third stimulus presentation here that there's something a little awkward happening. For the previous stimulus presentation here, you'll notice that that window, it isn't really over yet before the next green square has begun. And that's because we picked these green squares to be kind of long because we want to look at like the nice temporal evolution of this response. And in this case, the subsequent stimulus presentation came on before the previous box had ended. Okay, so that's kind of tricky, but I mentioned this because we need to really think deeply about things that are happening in a stimulus presentation at every moment in time. So for example, if we consider these time points that are just around the time that the stimulus was presented, like really these ones here, we can feel very confident in the response because it's the same thing happening for every stimulus presentation. The stimulus is presented and then nothing happens for a number of time windows. But this late time window out here, this is kind of the exception, because for most of the stimulus presentations, like this one and this one and this one, when you go out to this last stimulus window, it's always the same. There's just nothing happening. But for this one example here, when you get to that last time window, it's going to be kind of funky because for this particular instance, the next stimulus has come on. So I'm bringing this up to say that although it's really clear, usually what you're going to have as your 0 point, like in this case, the stimulus onset, you often will have to think a little bit about just how far out in time you want to go. And you don't want to keep plotting this continuously, because then this average here is going to reflect a mixture of trials. In some of those trials, nothing is happening because the next stimulus has not yet come on. And in other trials, a stimulus is on. And so you don't necessarily want to have a neural response that's going to reflect a mixture of these very different events if you want to understand something like what happens when the stimulus, just the neural activity when the stimulus goes on. So thanks very much. That's the end of my video. And I hope you enjoyed it and maybe have some questions.